G'day guys! Today we're going to be continuing on with mass spectrometry. So this is the table that you will get in the exam, or it'll look very similar like this, or in the internal you get this. And so you can see the relative mass of the peaks, and then you can see what ion fragments they correspond to. Note they're all positively charged because the mass spectrometer can only detect positively charged ions. Because when they break apart, you get a fragment that's detected, and this fragment, which has the electron on it, and it's got a radical, and it's undetected. So it always has a positive charge, meaning every ion fragment you detect has a positive charge associated with it. Okay? So I left you with this to do for the task yesterday, which is the mass spectrum for pentane. You should be very familiar with pentane, 5 carbons, just hydrogens on every carbon. And this peak, which is called the molecular ion peak, is 72. We go back here, we go all the way back. Hopefully I wrote it down somewhere. It'd be awkward if I didn't. I might not have wrote it down anywhere. Well, that's okay. Oh, no, sorry. We call M plus the molecular ion. So this is the base molecule minus an electron. Okay? So the top peak is always going to be M plus, or the molecular ion. It's the peak with the highest mass, so MZ ratio down here. This just means mass, and it's the mass of the compound. Base peak is the highest peak. This is the most abundant fragment of our molecule. So we go to pentane. This is the molecular ion peak of pentane, which is actually just the mass of the molecule. So pentane, 5 carbons, each carbon weighs 12, which is 60. Then you got 12 hydrogens on it, each weighing 1. That adds up to 72. That is our peak at 72. So this is just pentane. This pentane molecule has gone through the mass spectrometry. It's not been broken up. So this is just pentane, which we call M+. Or you could also just write out pentane, or like C3CH2 CH2 CH2 CH3+. Okay? That's this. Now, this peak at 57, if we go here, you can see 57 is either C4H9 or C2H5CO. There's no oxygen in pentane, so it's going to be C4H9, which is pentane, which has lost a CH3 group at the end. So what's happened is pentane, a CH3 has been cleaved off it, and it's become C4H9+. So you should have wrote C4H9+ here. What they've done here is they've just done M+ minus a CH3 group, which gets us 57. This is our base peak at 43. This is pentane minus a CH3 and a CH2. If we go back here, 43, so that corresponds to C3H7, which is a CH3, CH2, CH2. So in this case, 2 carbons, this has been cut off pentane to make C3H7. That's our highest abundance, which means this is the most common fragment in our set. The last peak I wanted you to identify was 29, which is just CH2 CH3+ at 29, which you should have identified with here. Okay? You need to include the plus, very important. So what about these other ones? What's happening here and here? These are 2 pretty big peaks as well. So what's happening is one of the fragments of hexane, which is the most common fragment, is this CH3, CH2, CH2. But this can also break down further just by removing a hydrogen each time, and this happens. You don't need to know this, since you don't need to know how it breaks down. All you need to do is identify some peaks. Okay? If you can identify some peaks and justify them, that is what you need to do in the internal for excellence. But I'm just letting you know it does break down further just by removing hydrogens. What fragments are likely to be responsible for peaks at 15, 29 and 43 in a sample of hexane. 29 and 43, I think we've already identified, be the same as here. Okay, so this will be 43, those are the same. But what about 15? What fragment would be identified at mass of 15 in hexane? Well, 15 in this molecule, if you think about what it could be, it can't be 2 carbons, because that would be too much weight. It has to be 1 carbon, which displays 12, and 3 hydrogens. So 15 is a very common peak. I'm surprised to not see it here. And 15 will be a CH3+. It's a very common fragment, hence it's listed here. 15 CH3+. And again, 29 will be this one, and 43 would be this one. Okay, so labeling the fragments. 58 will be, well, it's this butane. The base peak at 43 will be this common one, which is CH3, CH2, CH2. 29 will be CH3, CH2 plus. Notice all these have got pluses on them because they're positively charged. And those are how we label the fragments. So now we've learned about all 3 types of spectroscopy. We need to put it all together to write a good answer. So let's try this. Focus time. Compound C is known to be one of the following. So compound C is either pentane 3-one, pent 3-ene-1-ol, so an alcohol. This is a ketone. Own ketone, ol alcohol, as you can see here, or ethyl ethanoate, which means ethyl, this part of the molecule, ethanoate, this part of the molecule. So this is an ester. Analyze the 3 provided spectra and determine which structure is most likely. Alright, we can do this. So you are going to be given an IR spectrum for the molecule. Let's have a look at this. We've got some CH bonding here, which is CH stretching, sorry, and this big peak at 1700, which means there's a carbon double bonded to an oxygen. So here's how you would structure an answer. You've got a strong, sharp peak at 1700 wave number, indicating the presence of a carbon double bonded to an oxygen. You've got medium, sharp peaks at 3000, indicating presence of carbon-hydrogen bonds. The medium, sharp peak at 1100, which is this one, indicates presence of a carbon-oxygen bond. So that's all the evidence that is on this IR spectrum. Here is the evidence that is not on the spectrum. There is no broad strong peak at 3000, something like this, indicating the absence of an OH group. So just looking at the IR, we can tell it's not this one. Straight away, it's not this alcohol because it's lacking this big absorption here, the broad one. There is no medium sharp peak at 1600 to 1700 to indicate there's a carbon-carbon double bond, meaning it's unlikely to be this one as well, this double bond here. So we can discount this molecule based on this lack of evidence for it here. As there is no OH bond or carbon-carbon double bond, the compound is unlikely to be pentane, to be pent 3-ene-1-ol, pent 3-ene-1-ol, and the absence of a carbon oh, sorry. What? Sorry, no. There is no strong peak. Wait. I've missed it. I've missed one here. Sorry, I've just confused myself. Medium sharp peak indicating presence of a carbon-oxygen single bond. Well, I've messed this up when I've written notes. Let's continue onwards and see what we've got. So this thinks it's going to be... But there is a CO bond here. Okay, I'm just saying how to structure the answers. I need to fix this up. Sorry, guys. But basically, you can see the sentence structure that you use. You just highlight the evidence and go with that. But then you also get your carbon NMR spectra, and you've got 3 unique peaks. Note the peak at 75 is a solvent peak here, so we don't include that. And we've got 1, 2, 3 peaks here, indicating 3 unique carbon environments. Ethyl ethanoate has 4 unique environments. So you got here, 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 and here. Let me just move my mouse away so you can see that. We've got 4 unique environments. None of the carbons are the same. They're all different, meaning you'd have 4 peaks. Remember, the peak at 75 is a solvent peak, so we don't include it. So we've only got 3 peaks here. Okay. This is our alcohol. Again, we've got 5 carbon environments, so we eliminate it. This is our pentane 3-one. It's got 3 unique environments because these carbons at the end are the same, because it's symmetrical. These 2 are the same. So we've got 3 unique environments in pentane 3-one, meaning this matches the NMR spectra given. Then we label the peaks. The peak at 220 parts per million is likely to represent the carbon bonded to the oxygen. The peak at 35, this one, is likely to be the 2 carbons either side here. And the peak furthest upfield, which is this direction, at 10 parts per million, is likely to be these 2. Remember, you get a big data sheet given to you, so you can look for all this evidence and write it out. You just need to write out this sort of evidence, okay? Here we have the mass spectrum. The molecular ion is at Mz86, indicating a molar mass of 86 grams per mole. The base peak, which is the highest peak, at 57, which could be this. The peak at 29 could be CH3CH2 plus. Remember, these got pluses. This data further eliminates ethyl ethanoate as it's too heavy, and eliminates pentane 3-one as there is no this fragment at 58 or smaller, or a fragment at 54, which is this fragment. So we're looking at what evidence is shown by our spectrums, what evidence is not shown by our spectrums. So that eliminates it. As shown by the data above, the compound is this. Okay? That is the end of spectrometry. What you're going to do is, I'm going to give you some SciPad pages to do, and I'm going to put the for those of you that didn't manage to grab your SciPads. Oh no, you all have your internal SciPads, so that's fantastic. I'm going to set some internal SciPad pages for you to do to practice this. And then hopefully, when we go back to school next week, we should be able to do the internal. And because it's been a bit of a cluster muck-up this past couple weeks, the government has allowed me to give you a lot of extra help in the internals, which to help you along, and no one, basically, I can give you more help than I would otherwise be able to, because I've had to teach this online. Alright, thanks guys, and I'll see you next week.